4.2 graphs of equations and two variables. So for this installment, we're going to sketch graphs of equations using the point plotting method, find and use the x and y intercepts as aids to sketching graphs, test graphs for symmetry, and use the verbal problem solving method to write an equation and sketch its graph. So, point plotting method. In order to do the point plotting method, you need to first rewrite the equation by isolating one of its variables. Second step is make a table of values showing several solution points. You usually only need two. The third thing is plot in the rectangular coordinate system, and fourth is connect the dots with a smooth curve or line, depending on if it's a linear or non-linear equation. So for example 1, it says 3x plus y is equal to 5. So step 1 said rewrite the equation by isolating one of the variables. I'm going to put this in slope-intercept form. So I'm going to subtract 3x to the right. So I see y is equivalent to negative 3x plus 5. That was the first thing. They wanted you to rewrite it into solving one variable. Step 2 said make a table of values. So the table of values you can make using a t-table. I'm going to go negative 1, 0, 1, just so that I have to the left of the equation to the right equation. And we're plugging in these values in for the equation of negative x. So here we're going to see negative 3 times negative 1 plus 5 is what we're seeing. So negative 3 and negative 1 makes it positive 3 plus 5, giving me an 8. So our ordered pair is negative 1, 8. When we plug in 0, so we see negative 3 times 0 plus 5. So positive and a negative, where 0 is involved is still 0, plus 5, still 5. So 0, 5, known as a y-intercept. And then we're going to plug in 1. So negative 3 times 1 plus 5. So negative 3 times 1 is negative 3 plus 5 results in 2. So 1, 2. So we have 3 points that we can use to plot our graph. So we're going to do a simple coordinate system. Okay, so the first point is that when x is negative 1, the y is positive 8. So 1, 2, 3. So negative 1, 8, there's a point. It says when x is 0, the y is located at 5. So 0 is at the origin, and we go up 5 units. Then when x is 1, y is 2. So we plotted our 3 points, and then you need to draw. You can use a straight edge, a student ideal work. Just gonna do a rough sketch. It's coming straight down in the negative slope value. So this is what we're seeing. So remember, this is your x-axis. This is known as your y-axis. In example 2, we have the equation x squared plus y equal to 4. So to start, first thing we need to do is solve this to say y equals. So we are going to subtract the x squared to the right side. So we get y equals negative x squared plus 4. So this is our equation that we need to graph. In order to find our points, because it is a curved graph, we can tell by the power of 2, it's going to be a curved graph, a parabola. You can use the positive and negative values for the x, and we're going to create a t-table. So I'm going to say negative 1, 0, 1 is usually the easiest numbers to use for substitution purposes. So we're going to substitute in negative 1 in for x. So we see y is the same as negative, and I'm going to put negative 1 in parentheses because I need to do the math. And negative 1 squared becomes positive 1, but then we have that negative, makes it negative 1 plus 4. I'm getting a 3. So I have an ordered pair at negative 1, 3. Again, we do it with the 0. We're pulling in 0. So negative of 0 squared is still plain 0 plus 4, and we end up with a 4. So we're at 0, 4. And then they want us to plug in positive 1. So negative of 1 squared plus 4. Well, 1 squared is still positive 1, times the negative makes it negative 1, plus the 4 makes it 3, so we're at 1, 3. So we have 3 points to make a curved graph, which is basically all you need. So we're going to plot our points. So we have negative 1, 3, 0, 4, and 1, 3. And then you connect the dots and form your curve. Okay, in example 3, it says y equals the absolute value bars of x minus 1 close the absolute value bar. Just because of the absolute value bars, I know that we have a V-shaped graph, so not to be confused with the parabola, which is U-shaped. So this one just happened to be opening down. The V-shaped graphs, they could be a V-shaped opening up or down. It could be starting at the origin, going up or down, or it could be shifted left or right, depending on what the shift happens to be. So the first thing we want to do is, it's already solved for y equals value. We're going to create a table of values. And again, since it's a V-shaped graph, you can do positive and negative numbers again. So I'm going to do negative 1, 0, 1. So we have y equals x to the value of negative 1 minus 1. So negative 1 minus another 1 is negative 2, but since it's bars, it's coming out positive 2. So we have an ordered pair at negative 1, 2. We plug in 0. We have 0 minus 1. 0 minus 1 is negative 1. Negative 1 comes out as a positive 1. So 0, 1. And then we plug in positive 1. 1 minus 1. So 1 minus 1 is 0. So we have a point at 1, 0. And you can take another point if you wanted to make it so you can see the V again. And we can add a 2 to it if we wanted to. So we see 2 minus 1. 2 minus 1 is 1, which is a 1. So we have 2, 1. And then we plot our points. So we have negative 1, 2. 0, 1, 1, 0, 2, 1. And then we sketch our graph line in. So we can see that this is the 1, 0 happens to be where the peak of our graph is at. And our graph is opening up. So make sure you put arrows to extend the values. In example 5, they want us to find the intercepts and sketch the graph of y equals 2x minus 5. So intercepts. Things to remember back from your Algebra 1 days, x-intercepts and y-intercepts. X-intercepts, you're going to set the y values equal to 0 and solve for x. Y-intercepts, set the x equal to 0 and solve for y. So first thing they want to do is to find the intercepts. So we have our original equation that said y equals 2x minus 5. We're going to look for our x-intercept first. So remember, x-intercepts, we set y equal to 0. So here's our equation. Instead of a y value, I'm going to say 0 equals 2x minus 5. And I'm going to solve for x. So we are going to add 5. 2x equals a positive 5, and then divide by 2. So x equals 5 halves. So I have 5 halves comma 0 because I'm looking for the x-intercept and the y value is 0. Then we need to find the y-intercept. Remember that the y-intercept says you're going to set x equal to 0. So we have our equation, y equals 2 times 0 minus 5. So we get y equals 0 minus 5. So y equals negative 5. So we have the ordered pair 0, negative 5. These are your 2 points that you need to graph a line. So we're going to plot our 2 points. We're at 5 halves, which is 2.5 with a 0, and then 0, negative 5. straight edge and sketch your line. Okay, symmetry test. We have graph tests that we can do for our graphs. The first one is called symmetric with the x-axis. It means that if the xy is on the graph as well as it is on y equal to negative y. If it's symmetric with the y-axis, means that if xy is on the graph as well as negative xy. Symmetric with the origin is if the xy is on the graph as well as negative x and negative y. So we're going to show you some examples on how to prove this. So example 6 says, test the graph of y equals x squared minus 2 for symmetry with respect to the y-axis. So we want to make sure that it is symmetric on both sides. I can take our graphs and fold them over, and what I mirror on the left, I can see on the right. So they gave us our equation, and we're going to do a t-table. And again, I'm picking negative 1, 0, 1. I'm going to plug in. So we have y equals negative 1 in parentheses squared minus 2. Negative 1 squared is positive 1, minus 2 makes it negative 1. So we have an ordered pair at negative 1, 1. We're going to plug in 0. So y equals 0 squared minus 2. So 0 minus 2 is negative 2, 0, negative 2. And then we're going to plug in 1 again. Positive one this time. 1 squared minus 2. 1 squared is 1, minus 2 is negative 1. So I get 1 comma negative 1. Notice that we have values here that mirror the pieces. So negative 1, 1, negative 1, 0, negative 2, 1, 1. The y values right here are the same, negative 1 and negative 1. Remember, that is in the y position, which means with respect to the y-axis. So we're going to put our points. And we have our curve. Now the distance from the y-axis, this point here is 1 unit away. This point is also going to be 1 unit away. This point here and here. So they keep going the same values to the left and right of each other. Okay, algebraic test for symmetry. So algebraically we can test this for symmetry. For the x-axis, you're going to replace y with negative y to see if you get an equivalent equation. For the y-axis, you're going to replace x with negative x to see if you can get an equivalent equation. For the origin, you're going to replace x with negative x and y with negative y to see if you get an equivalent equation. So we're going to try all three properties with example 7. In example 7, they want us to test y equals 2x cubed for symmetry to the x-axis, the y-axis, and the origin. So we're going to start with the x-axis. So our original equation said y equals 2x cubed. Remember that for the x-axis, it said to replace the y with negative y. So first thing we're going to do, make it negative y equals 2x cubed. And notice that we do not get an equivalent equation of the original. So it is not symmetric with the x-axis. Then they want us to try the y-axis. Y-axis wants us to replace x with negative x. So we were taking our original equation, y equals 2x cubed, and we're going to substitute in negative x for x. We get y equals 2 negative x, and then I'm cubing it. This is still y. We still have 2. Negative x times itself 3 times is still negative, and so I'm still going to get negative x cubed. So your final answer is y equals negative 2x cubed. Again, that is not the original problem. So they want us to try, so it's not the original problem here. So now they want us to try it with respect to the origin. So respect to the origin says you're going to take your original equation and replace y and x. So I'm going to write it as negative y equals 2 with negative x in parentheses cubed. We are still negative y. This is now negative 2x cubed. And since we can divide by negative 1 to both sides, you get y equals 2x cubed, which is the original equation. So it has symmetry with respect to the origin.